Hello Patreon and welcome to your exclusive video and addendum to the most recent Flying V update. Today we're going to talk about potentiometers, and what I'm about to say is an excerpt from a very large script that I'm working on for a guitar electronics course that, when finished, filmed and edited, will be available to purchase through my website. We're still a long way off from that yet, but the potentiometer section of the script is just about finished, so this will be a bit of a sneak peek for you and a practice run for me when it comes to recording the real thing. Potentiometers are a form of variable resistor. They allow us to change the amount of resistance by turning the shaft. Potentiometers are used as volume and tone controls in our guitars, as well as the controls that change the sounds in our pedals and amplifiers. Most standard potentiometers will look like this: a round enclosed body with a protruding shaft and 3 contacts, or lugs. There are a great many types of potentiometer, but the ones that we want to focus on in this lesson are of the single turn variety. That is, the extremes of the resistance are bound within one single turn of the shaft. The diagram on screen shows how these operate internally. There is a track of resistive material going around the pot, and a wiper or slider attached to the shaft which contacts the track. This is how we select the level of resistance from the potentiometer. The 3 lugs on the pot correspond to the 2 ends of the track and 1 for the wiper. Measuring across the 2 outer contacts gives us the full resistive value of the potentiometer. This should match the nominal value printed on the pot. In our case, this 500k pot, which agrees with what we read on the ohmmeter within an accepted level of tolerance. However, if we measure between one end of the pot track and the wiper, we can see the resistance change as we turn the shaft. There are 2 main parameters one must consider when selecting the correct potentiometer for purpose: the resistive value and the resistive taper. The resistive value is the maximum resistance that the potentiometer can achieve. You will find many different values of potentiometer used for the controls in pedals and amplifiers, but in our guitars, the selection is considerably more limited. There are 3 main values of potentiometer commonly found within guitars: 250 kiloohms, 500 kiloohms, and 1 megohm. The main reason we see different potentiometer values used in different guitars is to do with how these resistive values interact with the guitar's pickups when used as a volume control. Higher resistive values of volume potentiometer allow more of the pickup's high frequencies to remain in the signal, while lower resistive values limit the amount of high frequencies in the signal. It's for this reason that you'll commonly find 250k pots being used in conjunction with single coil pickups. Single coils are typically very bright sounding pickups, perhaps too bright, so lower values of potentiometer are used to curb the brightness, giving the signal a more rounded sound. Humbuckers are typically darker sounding than single coils in general, so raising the value of the volume potentiometer to 500k prevents them sounding too dark. One modification often suggested for guitars with especially dark sounding pickups is to change the volume pots for ones of higher value, typically 1 meg, which helps retain more of the pickup's high-end detail in the signal. Of course, there are no hard and fast rules on this. You can use 250k pots for humbuckers if you want them to sound a little bit darker, or you can bypass volume controls entirely to get the full high fidelity output of the pickup without any resistive loading at all. The resistive taper of a potentiometer determines what function it can be used for. Linear potentiometers have resistance proportional to the position of the wiper. At 10 it'll be 100% of the resistance, at 5 50%, and at 1 10%. This linear proportionality is very useful for tone controls where you want to bleed out treble proportional to how far you've turned the knob. Turn down to 5 and you've removed half the total treble you can remove. Logarithmic or audio taper potentiometers have a resistive element whose resistivity varies from one end to the other. That is to say that 5 on the control doesn't equate to half the total resistance. The human ear perceives volume in a non-linear fashion. Our ability to sense differences in loudness between sounds varies with the overall volume level. We sense small differences in quiet sounds as being larger than the same small differences between louder sounds. Since we hear changes in volume in a roughly logarithmic way, it makes sense for our volume potentiometers to also have a logarithmic taper. This ensures that 5 on the control sounds roughly half as loud as 10, despite it not being half the resistance. Right, so back to the Flying V. I noticed after this round of upgrades that the pickups sounded better than they had before. They were less dark and compressed, and they had a more open, high-end fidelity. One thing I had been thinking about doing for the V was winding a new set of pickups, as despite the ones that are in there being powerful and sounding great the majority of the time, occasionally I felt that they just didn't have that high-end detail and clarity that my own pickups have. However, after I'd done these upgrades, all that had changed. These pickups sounded exactly as I wanted them to. Now, I could make some jokes about finally plugging that bridge hole, keeping all the tone in the guitar, and that's what the difference was, but obviously that's not it. Initially, I put it down to the fact that I had a fresh set of strings on there, which is probably a big contributing factor. Strings lose their ability to vibrate in high-order harmonics over time, so get duller the longer they've been on the guitar. But it felt a little bit too much of a change to just be the strings, and out of curiosity I decided to measure the old volume potentiometers that came out of the guitar, and I was a little surprised at what I found. The value of these pots was 250 kiloohms. Now that's a little unusual for a humbucker equipped guitar, but perhaps Gibson felt these pickups were a little too bright and needed darkening up for their goth line. Anyway, changing these up to 500k pots and that fresh set of strings is what I suspect lifted the high-end limitations of this guitar. I guess breaking that tone pot shaft was a good thing after all.